Have you ever wondered how companies like Netflix know exactly what movie you want to watch next? Or how your favorite sports team seems to make all the right decisions? The secret behind a lot of this is something called data analysis. So what exactly is data analysis? Imagine you have a giant box of Lego bricks of all different shapes, sizes, and colors. Right now, it's just a messy pile. But if you start sorting them, counting them, and looking for patterns, like maybe you have more red bricks than blue ones, you're starting to understand what you have. That's data analysis in a nutshell. It's the process of cleaning, changing, and studying data to find useful information that can help us make smart decisions. Now, you might be thinking, that sounds complicated, and it can be, but we have powerful tools to help us. One of the best tools out there is the programming language Python. Why Python? Well, for a few simple reasons. First, it's famous for being easy to read and write, almost like plain English. Second, Python has an amazing community and incredible free libraries, specifically for data analysis. And finally, it's used by everyone from small startups to giants like Google and NASA. So it's a fantastic skill to learn for your career. Today, we're going to do a simple but very real data analysis project together. We'll be using a famous dataset about heart disease to see if we can uncover any patterns or insights. First, import all the libraries. Pandas helps us load and manipulate tables. Matplotlib is the classic plotting library, and Seaborn sits on top of Matplotlib to give us nicer, higher-level visuals with less code. Now, let's load our data using Pandas. Our data is in CSV format, so we can use Pandas' built-in method, read CSV, and then peek at the top 5 rows. See columns like age, sex, call? That's our playground. Let's quick check our data. The df.info tells us if any data is missing or wrong type. In our data, there are 920 rows and 16 columns. That's a good chunk of data. Some columns like age, sex, and num have no missing values. Yay. But others, for example CA and slope, have quite a few gaps. We've got a mix of numbers, int64 and float64, and categories, object. Knowing where data is missing helps us decide if we need to clean or impute later on. The df shows mean, median, min, max, and quartiles of numerical columns. This helps identify outliers or weird values at a glance. Here's df.design for our numeric columns. Average age is about 53.5 years. Blood pressure, TRES BPS, averages around 132 millimeters of mercury. Min shows some zeros, likely missing or placeholder values to watch. Cholesterol average is relevant 199 milligrams per deciliter, but max jumps to 603. Possible outliers. Old peak has negatives, downhill ST depression, and CA shows many zeros because of missing data. The num column averages 1, meaning roughly equal distribution of disease presence. Now let's quickly do data cleaning. df is null. Sum tells us how many empty cells are in each column. Columns like TRES BPS, call, and thalch each have around 30 to 60 missing entries. Slope, CA, and thal have hundreds of gaps. These we may drop or impute later on. When there are missing values in our data, we have two choices. Drop rows where missing values found, or fill them with mean, median, and mode, or an advanced method like k-nearest neighbors imputation or model-based imputation. Now let's do some quick data visualization. This will help us to easily understand our data and extract meaningful insights. I draw a histogram on age data. Histogram show as the distribution of data. Check out this histogram with a smooth curve on top, our age distribution. You can see most participants fall between 45 and 65, with a peak right around 55. A handful of younger and older folks too. but the bulk is middle-aged. Exactly where heart disease risk ramps up. Let's check heart disease by sex. Are men or women more affected? To find out, we draw a count plot on sex data, with target column which is num in our dataset. From this graph, we can clearly see that males more affected from heart disease than female. By the way, in our dataset, there are 4 types of heart disease. 0 means no disease, and from 1 to 4 mean have a heart disease. Next up, let's explore how cholesterol and maximum heart rate relate. This can reveal hidden patterns about disease risk. Here's our scatter plot. Each dot represents a patient, colored by their num value. 0 for no disease, and 1 to 4 indicating increasing severity. On the x-axis, you see cholesterol levels. On the y-axis, the maximum heart rate achieved during exercise. Key takeaways. Patients clustered toward the upper right, high cholesterol, high heart rate, are mostly healthy, lighter dots. Patients in the upper left to mid-left, lower heart rate but moderate to high cholesterol, show darker colors. These are the folks with heart disease. This visual helps you spot that lower max heart rate combined with higher cholesterol often signals heart issues. That's a clue for clinicians about which metrics to watch closely. Now, chest pain type. There are 4 kinds. Let's see which one links most to heart disease. Here, CP has values 0 to 3 for different pain types. The bars show how many in each type have disease versus no disease. You can clearly see that those patients who have asymptomatic type pain have more chances of type 1 heart disease. Finally, let's check fasting blood sugar. Does high sugar level mean more heart trouble? You can see if a patient does not have fasting blood sugar. They have less chances of heart disease. And that's a wrap on our UCI heart disease deep dive. Today you saw how to load and inspect data with Pandas, clean missing values, generate summary statistics, visualize distributions and relationships using Matplotlib and Seaborn. Those building blocks, Pandas for data, Matplotlib, and Seaborn for visuals, are the foundation for any data analysis in Python. Try applying these steps to your own datasets, and customize the plots and cleaning methods for extra practice. If you found this helpful, smash that like, subscribe for more Python and data science tutorials. Thanks for watching.